Geometrical meaning of a zero of a polynomial. A real number k is a zero of a polynomial. If pk is equals to 0, let us take a linear polynomial where y is equals to ax plus b is a straight line. Let us see an example for it. We take an equation y is equals to 3x plus 6. Now, in previous classes, we have learned how to make a graph of it. As we have y is equals to 3x plus 6. Now, recall the previous class and simplify this thing. We get 3x plus 6. In the place of x, we'll take 0 and we'll try to find out. 3 into 0 is 0 plus 6 will give you 6. 3 into minus 1 plus 6 will give you 3. 3 into 1 plus 6 will give you 9. So we get this equation as x, y. In x we have 0, minus 1 and 1. In y we get 6, 3, 9. According to this table, if we take a graph paper and find the number on it, while looking to this graph, we have to place these points on the graph. First point is 0 and 6. Second point is minus 1 and 3. Third point is 1 and 9. Now all these points are placed and we can see these points are particularly placed. We can take a scale and draw a line through all these points. Now as you can see, this line is drawn straight. From the graph we can see that y is equals to 3x plus 6 intersect x-axis at minus 2 and 0. If 3x plus 6 is equals to 0, then it gives x is equals to minus 2. Therefore, 0 of polynomial of 3x plus 6 is minus 2. Now, let us take a graph of quadratic polynomial. In quadratic polynomial, let us take equation x square minus 5x minus 6. Now we can also take as y is equals to x square minus 5x minus 6. So for various values of x, the corresponding value of y are, we'll take x and y. As we have simplified earlier, we can simplify in this by the numbers as in x we have minus 2, minus 1, 0, 1, 2, 5 and 6. In y we have 8, 0, minus 6, minus 10, minus 12, minus 6 and 0. Now these are the points. Now let us take a graph and arrange these points on their correct places. First is minus 2 and 8. So minus 2 and 8. Second is minus 1 and 0. Third, 0 and minus 6. Fourth, 1 and minus 10. Fifth, 2 and minus 12. Sixth, 5 and minus 6. Seventh, 6 and 0. Now, just roughly connect these lines, we get the graph of quadratic polynomial. For this graph, we can observe that the coefficient of x square in y is equals to x square minus 5x minus 6 is 1, which is a positive real number. So the parabola opens upward. The parabola intersect x-axis at 2 points, minus 1 and 0 and 6 and 0 respectively. So this quadratic equation has two distinct zeros at minus 1 and 6. By algebraic method, we can factorize the given polynomial into two distinct linear factors. That is x square minus 5x minus 6 is equals to x minus 6 and x plus 1. So parabola intersect x-axis at 6, 0 and minus 1, 0. Now let us study the graph of cubic polynomial. Cubic polynomial. Let us take one more equation for cubic polynomial also, where we get y is equals to x cube minus 4x. For various values of x, the corresponding value of y are x, y. Enter some numbers. We'll draw a table and we'll put some values in it. X we get minus 3, minus 2, minus 1, 0, 1, 2 and 3. In y, we have minus 15, 0, 3, 0, minus 3, 0 and 15. Now, as we get this table, let us take a graph and arrange this point on their correct places. In this cubic graph, we have to place first is minus 3 and minus 15. Second, we have minus 2 and 0. Third, we have minus 1 and 3. Fourth, we have 0, 0, means only 0. Fifth, we have 1 and minus 3. Sixth, we have 2 and 0. Seventh, we have 3 and 15. From this graph, we can observe that y is equals to x cube minus 4x. Intersect x-axis at their point, which is minus 2, 0, 0, 0 and 2, 0. Hence, minus 2, 0, 2 are three distinct real zeros of this polynomial, which can conclude that in general polynomials of degree n can have the most n zeros, or geometrical zeros of a polynomial is x coordinate of the points where its graph intersect or touches x axis.